Okay, let's say you have a fascinating vertical takeoff and landing airplane like this. This is the Beta Alea prototype. If you want a flight control system for an airplane like this, one possible way you could do this is artificial stability VTOL tab, which is where you are now. The question we're going to ask at this point is, how do you control an airplane like this in hover? What's the way you want to control those four props that you see at each corner hovering the airplane? And this is a real airplane, by the way, and it has actually hovered. It's electric as well, no fuels used. Why don't we just show you with this quick and dirty little drone I got here that'll be a stand-in for Alea. Much less exciting, but it's the same idea. How would you control a vehicle like this? Well, when it's in hover, what you're probably going to want to do is say, if I'm going to move the stick all the way to the right, then I want to roll at a certain rate over to the right. All the way to the left, I want a certain left roll rate. Pitch all the way down, I want a nose down roll rate. Pitch all the way up, I want a nose up roll rate. This is one possible way you can control a vertical takeoff and landing airplane. And then rudder, of course, causes a yaw rate. And an interesting thing about this is we have to do these rates with no ailerons, elevator, or rudder. There is no aileron, elevator, or rudder. All you can do is adjust the throttles. So how do you adjust the throttles to control this thing? Well, if this is a hover, then if you apply some more power up here, it's clearly going to rotate up. Apply more power in the back, it's going to pitch down. Apply more power off to the side, it's going to roll. And then if you apply power in clockwise or counterclockwise caddy corner, then it's going to yaw. And so that's how you can get pitch, roll, and yaw, all by doing nothing more than adjusting the throttle on these propellers. But there's one little headache with this, and that's if you control a certain roll rate, you might crash the drone if you're not constantly paying attention. That doesn't sound fun. Don't you want this thing to like level itself off like a boat? Like when I'm sitting in a boat, I really want the boat to level itself off. And I've certainly been in a canoe that's tipped over. But ideally, you lean off to the side, the canoe rolls, and then if you set yourself center, the canoe levels itself off again. A boat levels itself. Shouldn't an airplane and hover do the same thing with the flight control system? I think so. And so to answer all the questions that I've just asked, what type of flight control system can be useful for this drone or for this airplane, this is one possible answer. So check the box. Use this quad rotor drone style system to adjust all flying surfaces and throttles for pitch, hitting, and roll rates with stick input. So what's interesting is everything we're about to do is going to control the ailerons, elevators, and rudders at all speeds. So whether you're in hover, whether you're in forward flight, ailerons, elevators, and rudders are still going to move to try and stabilize the airplane. Now when you're in hover, obviously the ailerons aren't going to do anything. The elevators and rudders aren't going to do anything. There's no speed over them. But we still move them anyway because as the speed builds up, those ailerons, elevators, and rudders become more and more useful. So what's interesting about this page is it's used for vertical takeoff and landing airplanes where you move the flight control surfaces, aileron, elevator, and rudder that this airplane has. So how do we do this? Well, in hover, we want to max desired roll rate, pitch rate, and yaw rate, and see my video on the Art Stab tab here off to the left to get a full explanation of that. But what this means is as we move the joystick around, we want to have certain rotation rates of the vehicle. And as well, we don't just want to set our flight controls and throttles based on what the roll rate of the airplane is now. We want to set them based on what the roll rate will be in the future at our current accelerations. In other words, a good flight control system always has to look into the future a little bit. If it doesn't, it's always going to be behind. It's going to drive like a drunk person driving a car, always swerving because their reflexes are always a half a second behind. Why? Because it takes time to figure out what the airplane is doing. It takes time to move a flight control system. It takes time for a propeller to spin up. It takes time for a gas turbine engine to spin up. It takes time for an airplane to start accelerating into velocities and positions. All these things take time. Because of that, if you just make a flight control system that steers the airplane based on what it's doing right now, you're always going to be late and you're going to swerve back and forth like a drunk driver. A flight control system needs to extrapolate into the future, making the flight control decisions based on what the airplane will be doing in the future based on the acceleration it's going under now. So this flight control system that I found works well for this airplane looks a half second in the future for roll, pitch, and yaw. All right, let's do one case. Let's walk through it. So what this means is if I put the stick hard over, I want the airplane to roll right, let's say at 30 degrees per second. And we're going to set our ailerons and throttles and whatnot based not on the current roll rate, but on what the roll rate will be in a half a second at its current acceleration. And so if the roll rate will be 30 degrees per second in a half second based on the current acceleration, Well, that means we're going to be at 30 degrees per second soon. We've commanded 30 degrees per second. Back off the ailerons now. You see, it's an anticipation. It's critical. All right, now what about the auto level? Remember I was saying airplanes in hover should level themselves off like a boat in a perfect world? Auto level roll, look ahead, and auto level wings in roll. So what that means is in 2 seconds, this thing is always going to try and add a roll rate, add ailerons to level the thing from whatever attitude it is back to level in 2 seconds. So if you're off 30 degrees in roll, it's going to try and roll you back to level at 15 degrees per second. It always tries to take you 2 seconds in, to level the thing. And do that again with the look ahead of half a second. So don't make the decision on what the roll is now. Make the decision based on what the roll is going to be in half a second. That's the anticipation. And then what about the aileron, elevator, and rudder? Ooh, look at that. I entered 0 in hover for this flight control system because I just wanted to go with the direct stick input put in by the pilot for the aileron, elevator, and rudder. So it's not going to move the flight controls at all. And if I wanted to, I easily can. Let's say we put in 20%. Well, what that's going to do is just take the joystick input that I've got and add 20% of a throttle input, or excuse me, 20% of an aileron input for every 30 degrees per second of roll I'm off. What's interesting is I can enter 0 though because the ailerons, elevator, and do nothing in hover, and having them just following the joystick is going to be fine. But where we really need this flight control system to apply in hover is, of course, the throttle. So throttle per 30 degrees per second air and roll, 0.5. Throttle per 30 degrees per second air and pitch is 0.5. Throttle per 45 degrees per second air and yaw, 0.5. So what that means is, if this airplane is in hover and there's 0 and it's moving at 0 degrees per second, and I hammer this all the way over to command 30 degrees per second to roll, well, it's going to add 50% throttle on the left rotors and take away 50% throttle on the right rotors to get the thing to roll. And we're applying this. I can check the little boxes for what engine this flight control system is applied to. You'll notice it's applied to 4 out of 5 checkboxes. Why isn't that flight control applied to the 5th engine? The answer is, well, the 5th engine is this little propeller in the back. We're not going to try and adjust the throttle of this thing to hold pitch, heading, and roll. We adjust the throttles on these things to hold pitch, heading, and roll. And so what we see here, finally, to summarize, is a flight control system that can be used for a vertical takeoff and landing airplane, where we command pitch, heading, and yaw rates. We look a certain distance into the future to see what the rates of the airplane are going to be. We try and level the airplane in a certain number of seconds to level it off like a boat. The wing leveler looks ahead a certain amount of time to anticipate where that airplane is going to be and move the flight controls to intercept that. And then we call for a certain amount of aileron, elevator, rudder to get added to our flight control input for every degree per second of error. We can do 0 for a VTOL because when you're hovering, the physical controls don't do anything. So you're fine just following the stick directly. And we do a certain throttle adjustment to apply more juice to the left side or the right side or the front or the back or the clockwise, counterclockwise caddy corners in the case of yaw to get the airplane to follow the roll rates that are commanded. All done with throttle. And this is the ALIA 250 airplane. You have this in X-Plane. You can take this for a flight and see how it works.